Yeah, welcome back, grade 12s, teachers and learners. Addition is another reaction of the 5. This is the last reaction in the chemical properties. So very easy, as I have already written here, to say in addition reaction, we are moving from double bond to single bonds. Therefore, as long as the double bond is the origin, or is where the arrow is originating from, therefore that reaction is addition. Now we've got 4 types of addition reaction. We'll start with the 2 most important ones. The first one being the hydrogenation. Hydrogenation means that now we are adding hydrogen. In this case, we have got let's say an alkene like propene. I say the word prop in these reactions is very, very important. Then propene plus hydrogen. This will be very important because we need a catalyst here. The reaction continue, we need a catalyst, either platinum, nickel, or even palladium. So then we'll form an alkane, which is this propane. We are moving from 2 reactants, 1 product. That is the first one. The second one, which is also very important, is the so-called hydration. Hydration, in essence, we are adding water. And this one, remember, there's one substance that loves water, that is sulfuric acid. Again, here, if you take propene, you have propene. Propene undergoes hydration. We're adding water. Then water is added, and then we'll need also concentrated sulfuric acid, substance that loves water. Where water is involved, sulfuric acid is there. Then the product will be an alcohol, which will be 1, 2, 3, and then alcohol. Then this one, let's talk about it, to say when this double bond breaks, it will form 2 bonds here that will require to be filled in again. In this case, the first, because water is having HOH, therefore the OH is the negative part of this water, and hydrogen will be this one. So hydrogen, when we add, we are using the so-called Markovnikov rule, but just a rule that you should know. Normally we say when hydrogen is added, it will be added to the rich carbon, or the most bonded carbon, or the more bonded carbon, whereas the remaining, which is the OH, will be now going to the less bonded carbon. Therefore, hydrogen will go to carbon number 1, and then the OH will be at carbon number 2. Therefore, mean that the major product will be propan-2-ol. Whereas the minor product now will be propan-1-ol. That is in this case of hydration. These are the 2 important reactions, because this one requires, out of the 4, requires reaction conditions. Remember, the other one is platinum, and then this one requires concentrated sulfuric acid. The next reaction, number 3, will be where now we are adding halogen, the halogenation. We are adding bromine, or we are adding chlorine. In this case, fine. If we still take propene, the same thing will apply. Again, in this case, if you add a halogen, that's very important. Then we add bromine. Therefore, this will be now 1, 2, just in the case of hydrogen, you'll find this is the original. This, The first carbon was having 3, then the 2 bonds will come from the double bond here. Therefore, it means that the 2 bromine will be now find the home in this one, these 2 bonds, and then now the new product is a haloalkane, which is called now 1,2 dibromo propane. That is the halogenation. If it was chlorine, it will be 1,2 dichloropropane. Very important. The last one is where now we call it hydrohalogenation. We are hydrohalogenating. Halogenation. We are adding hydrohalogen, HCl or HBr. So if we take the same, let's take a but1-ene, which will be the same as this one of propene. So this will be the case. Let's say we are using the same rule that says if this one is HCl, then we'll form a new product, 4 bonds. Yes, the first hydrogen was having, carbon was having 2, this one was 1, this is 2, and then this one is 1, 2, 3. Fine, they have got these 2 bonds. If you look at this one, we say hydrogen always go to the rich carbon or the more bonded carbon, therefore hydrogen will be here, the remaining will be either Br or Cl will be here, therefore this will be now 2-chlorobutane. 2-chlorobutane from but1-ene. So these are the 4 addition reactions. Very important. In addition, now we can summarize it this way to say, in addition, if I've got 2 reactants, if it's addition, then the product will be only 1. That's the case. So because we are adding, we are moving from the double bond to single bonds. So in a nutshell, if you still remember, we said substitution, if it's A plus B, I will have C plus D. A substitution. Elimination, if I've got A plus B, I will have C plus D plus E. That is elimination. And then now addition, if I've got A plus B, then I will form only C. I think you see the difference between the 3 reactions now. This will be substitution, whereas this one is elimination, and this one is addition. So in addition, less products, elimination, more products, substitution, the same. I hope you get the difference between the 3 types of reactions and you can differentiate them. Very simple. We said there are 3. Otherwise, if they say name the type of reaction, you can call all of them addition reaction, but there are 4. So first two very important to say they need those reaction conditions. We'll analyze that one in a flow diagram. So quickly I can draw one simple flow diagram here that we can analyze. Let's say, for example, I given this one as an alcohol plus compound P forms reaction 1, and then produces this one, ethyl propanoate, and then alcohol, this is the case, undergoes this one, and this is reaction 2, and it produces alkene, and then P is this one. Now you can tell from this one to say, obviously, if they can say analyze this table, I can tell if this one is an alcohol, the alcohol according to the name here, it will be ethanol. And if this one is ethanol, then the acid will be propanoic acid. Propanoic acid. Fine. And then that reaction 1 is esterification. Esterification. That's how easy it is to analyze the table. And reaction 2, because this one is ethanol, therefore the alkene will be ethene. I'm going to remove water. Reaction 2 will be addition reaction. Addition, I can even name the type of addition, which is dehydration. Oh wait, it is not addition, elimination. Elimination. Then it will be dehydration. That's how easy. Remember, in this case, we'll need also concentrated sulfuric acid. Also, in this esterification, I will need concentrated sulfuric acid and plus heat. So that will be the case. In a nutshell, this is how you can analyze this one. You can draw this one. If I can put another one and say this is X and name inorganic product X, we know that this X will be water. That's the case. And then draw the structure. I can draw the structure. 2 carbon atoms from the alcohol. They are normally joined by oxygen with the acid site. Acid site has got 3. Then remember the COCO. COCO, the functional group. Therefore, the remaining bond will be for hydrogens. This will be my ester, which is ethyl propanoate. Ethyl propanoate. I hope you see how easy it is to deal with organic molecules, especially if you're coming from the previous 2 sections. We'll see the exam type questions in the next session. Thanks a lot.